Good morning, good afternoon, and good evening, everybody. Welcome back to another Conversations on Retail with on-shelf availability focus. My name is Mike Graen, and I'm your host. And I get to introduce a guy that I have been working with for at least 22 years in the RFID space. And everybody knows him as Senthil. But the interesting thing is nobody knows his last name, because it's like 47 consonants, 17 vowels, and a couple of dashes. So, Senthil, why don't you give us your full name and give us a little background about yourself?
Sounds good, Mike. Thank you. Thanks for having me on the podcast. You had asked for my full name. I realize we have only 60 minutes, so it may be tough getting through. But as I said, most of the folks that know me as Senthil, and pretty much everyone that I grew up with knows me as Senthil. And I do really have a very, very, very long last name, but it's essentially my dad's name and my granddad's name. So that's pretty much it, So I come from, a system where they, instead of a typical family name, they basically attach your father's and sometimes your grandfather's name. So that's essentially it. And whenever people try to address me with my last name, I'm like, who's calling me granddad? But anyway, nice to be here.
So what is it? We're all waiting. Give us your entire full name. Not that you use, not when you go to a restaurant and say, who's the name of the table, and you give them this name. What is your full name? Because I don't think most people know that.
No, and then there is not a system that can fit everything as well. So the only place where I have my full legal name is my passport, but every other system, there is not a single system that can fit my full name. So depending upon where you go, whether it's a university, whether it's the driving license, or whether it's an airline reservation, they chop it up. So it's always fun trying to, figure out what part they chopped out. But, my full legal name first name is Senthil Kumar. And the last name is Chinnappa Gounder, which is my grandpa's name, and Periyaswamy, which is my dad's name. And I think it's 40 or 50 characters, but I have not had the time to go through all of it.
Oh my gosh, longest name in the world. Now, I've also seen it as Senthil Gounder P. What is that? It's a derivation.
Again, different people chopping it different ways, right? And the biggest challenge I had was I don't really pay attention to it. I'm like, yeah, let's have fun with it. As long as people know me as Senthil or the guy with the longest name, that gets me to places. But as Mike, you alluded to, we have known each other for 22 years, and we all started at the University of Arkansas. And one of the amazing things that the University of Arkansas does when you graduate from Arkansas is they put your name on the sidewalks. It's called the State Walk, right? So, and I got 2 degrees from Arkansas. One was my master's and one was my PhD. And at both of those instances, they came back and said, hey, we can't put your whole name in a sidewalk because our sidewalks are only 6 feet long. You got to chop it up, and that was the longest and hardest I had to think of. Do we get more of my father's name or do I get more of my grandfather's name? And that's why I had to get my PhD too, because when I got my master's, I had to give it for my grandfather. But then I felt bad for my father, so I had to go and get a PhD to, get him in. So I'm there twice on the sidewalks of Arkansas, but 2 different versions.
On most of the 6x6 squares at Arkansas, there's 150 names. On yours, there's 1. It has to tap around 14 times to be able to get it. So, well, let's get in a little bit of the podcast. That's always fun to talk a little bit about the fun part of your name and stuff. And I always tease you. But we had a board meeting a couple weeks ago, and you also Senthil, and I go, "What's your last name?" I thought about yelling that out. Yeah, that's just not fair. So, 2005 to 2005. You and a guy by the name of Justin Patton were, I think, relatively new out of school, and Dr. Bill Hargrave came and said, hey, why'd you like to come and be part of an RFID lab? And you went, a what? So tell us about you and the lab, and what exactly does the lab do? I think a lot of people have heard of the Auburn RFID lab. I'll bet you that most of them don't know everything that you do, but just talk a little bit about what you do at the lab.
Yeah, so we got started at the lab when we were still students at Arkansas. So I was getting my master's at that time. Justin was almost done with his master's at that time. And I was in computer science. He was in computer engineering. And Dr. Hargrave was in the business college. And, and he has been working with Walmart for a couple of years at that point, trying to figure out, hey, will this technology be relevant to what Walmart is trying to solve from a business perspective. And around 2005, they had arrived to the conclusion, yes, there is, value in this technology. This technology is feasible. So let's try and make this as a reality. And at that point, Dr. Hargrave and the team at Walmart decided, hey, it would make sense to create an RFID lab that would serve as an educational resource to the community, to the suppliers, to the technology providers that are getting on board, really quickly, and also do some of the fundamental research that's required on the business side. And at that time, he basically reached out, to us and said, "Hey, do you guys want a job?" And we were like, "Oh, okay. Is it a paid job?" And the answer was yes. And we said, "Yeah, we are up for it, right?" So, we are hungry grad students, and we started in the lab in 2005, it has been a short 19 years. We didn't really think we would be doing this for 19 years because in a typical academic environment, you work on a research project for 2-3 years, wrap it up and move on to the next thing. But with RFID, it has been a fantastic journey where we have sort of grown with the industry, and I wouldn't have it any other way. And we were at University of Arkansas for the first 9 years, and then we moved to a place called Auburn University, and we have been there for officially 10 years now. So we have now been longer in Auburn than in Arkansas, but it doesn't feel like it. The early days were, I would still consider the early days a way lot more fun than today. Today we're still having a lot of fun, but the early days we were literally, building things in the lab. The role that we have played in the industry has sort of evolved as the industry has evolved, but the core mission of the lab, which is to focus on the business case and the business value of the technology, educating the community both on the business and the technology side, and then serve as a platform for everyone to sort of come together and work. And then one of the things that we have been doing, not really quite for 20 years, but more for the past 15, 16 years, is do a lot of things that helps with the implementation of the technology as well. Because early in the days, we figured out our role was pretty, we thought, hey, once we see the value, once people make the decision, we thought our work was done. But we were realizing that there is a lot more work that happens while you deploy this technology and roll this out than, even in the initial decision of choosing something like RFID. So we have focused a lot on that, and here we are.
Here we are. So your role specifically, here's the way I like that. Rather than giving us a 20-minute dissertation about your role description, it's typical day looks like for you. Because what I would say is you are the technical expert. You probably don't really like to be referred to that, but when somebody wants to know how RFID really works, they don't ask anybody at the lab except you. Tell us how this works, right? So give us the understanding of this. So what does a typical day look like for you? And weave into that kind of what's the role that you have at Auburn?
Absolutely, Mike. So my official title is Director of Research and Technology. But as you refer to, whenever there is a tech question, hey, let's ask Senthil, is not unusual. My typical day, it serves, let me step back a little bit as well. So when we started the RFID lab, the mission has always been to support the business case and the business value. But, someone like me and even Justin come from an engineering background, right? So we learned technology growing up, and it's still our passion. So what we tend to do is we tend to have a fundamental understanding of what the technology can do, and more importantly, what the technology cannot do. So it's really having that and then working with businesses. And when they come to us with problems they would like to potentially solve with RFID, it's basically guiding them saying, yep, that is feasible. It's something that we can currently do. It has been done. Or it could be something like, hey, this is something that's currently not feasible, but might have a solution in the near future if we really put our efforts to it. Or this is not something that RFID cannot do. And we need to probably look at something else. In that way, we are setting the right expectations, on the end user side. Typically, on a typical day, I sort of look at my role in three different buckets. The first bucket is, I tend to work with a lot of technology companies, both in the mature market space where people have developed technologies and have been using it for years and months at this point, trying to understand how it works. But I also spent an equal amount of time with technology companies that are developing stuff that might not be ready for real time, but is up and coming. And with that interaction, I sometimes we work back with the community, getting them my perspective on what their technology can do, and what are the things they could potentially do that could help fill the gaps. Because a lot of times the technology, especially in the second category where companies are developing technology for an anticipated market need, they have done their market research, they understand their product. But we also tend to work with a broader set of end users. So we give our perspective as well on, hey, these are things that would be a fantastic fit. There is a market need for it. But there are certain things that you might not have focused on, but there is definitely an opportunity there. But then that's probably about 30% of my day, if you will, working with the technology companies. The second, I would say, part of it, the other 30% is I tend to work with end users as well, trying to understand the business challenges that they are trying to currently solve and what do they have down the pipeline. Because, we believe firmly that, technology development for the sake of technology development is not as impactful as developing a technology to match a business need, right? So we do spend a lot of time getting into the weeds of day-to-day business operations, whether it is retail, whether it is aviation, whether it is logistics, whether it is food, trying to understand how their businesses work. And then, and in that way, when we get to evaluate technology, whenever we work with the technology companies, we bring that perspective in. And then I would say the last part of it would be in a lot of scenarios where we are bridging the gap between both the technology companies and the end users. So we work with both of those individual entities in a standalone manner, but there are enough projects and programs where sort of the rubber hits the road and where there is things happening, and we sort of act as a bridge between translating what the business needs are to the technology companies and vice versa as well. And then, and if you look at the people that we work with, 50% of our time is spent with the industry, but the other 50% is actually working with our team as well. We used to be a really small team back when we were in Arkansas. It was half a dozen people, and that felt like a lot. And by the time we moved out of Arkansas, it was 30 people, and we had to really, build our team from scratch when we moved to Auburn. That looked like a lot. And currently we have about 120 students, about 12 or 13 full-time staff. So it's really coordinating what's happening externally with our industry partners to our teams internally and vice versa. So it's a good mix as well.
All right. So I was trying to interrupt you. You threw out an acronym, which we love to do, ARC. Spend time with the ARC team. I don't know that most of the people in the audience maybe even knows what that means. What is the ARC team?
So the ARC team was created in 2009 to answer the question, what tag should I use? Right. So whenever we started working with end users, we were focusing on the business case and the business value. And then when they made the decision that they are going to do RFID, and the question that invariably came in every single deployment was, hey, I've got all of this figured out. There are these, at that time, 10, 15 tags in the market. Which tags will work, right? And the way the technology works is we are still at a phase where we have to choose the right tag for the right application. I mean, that broadly applies to a lot of the other technology decisions as well. But, more than anything with tags, the way the physics work, depending upon the product you're tagging, depending upon the reader infrastructure that you're having in place, and the use cases that you have in mind, you have to sort of choose the right tag, if you will. And we were answering these questions on a one-off basis until 2009. And in 2009, we thought, hey, since this is a question we are answering, can we do this in a more structured and scalable way? In that way, when this question goes from, being asked from 5 different companies to 50 companies or 500 companies, can we still answer that question in that way, to support their needs, right? So that's the whole idea behind the program. So the ARC team does a lot of work, understanding the requirements or needs of the application, and then creating what we call as specs for the use case. And then once we have the spec, they test a lot of products that come into the market, RFID tags, and then they approve the RFID tags for different specs, if you will. So if you are an end user, and if you identify that I need spec Y, then you have a list of tags that are already quality and performance certified, so you can basically use those tags and be confident that they are going to work and deliver, the value that you're expecting from it. And it was something that was originally created with the end users in mind, but it also, did a couple of other things that we were not anticipating back then. One was it helped the technology community get a clear understanding on what the expectation from the end user was. Because before then, they were developing tags. Tags were being developed way before ARC was, created. But a lot of assumptions went into place, and there was a lot of gap between the people who were really developing the technology or really developing the tags and the end application. And the data that typically flowed from that end user application to those engineers that were building those products went through 2 or 3 layers, and a lot of things were lost in communication, right? So ARC helped standardize the requirements from an end user perspective. So in that way, if you are an engineer sitting anywhere in the world, you have a document in front of you that says, this is what is needed from an end user perspective for this application. So if I build a product that meets that spec, then I don't have to, figure out what they really need. So it really helped standardize and communicate the requirement. And then the last thing that happened, especially with the way the industry scaled, was it helped align and create a standard across the industry. So if you are a retailer that's going into tagging electronics and you're the first one, you do in fact do a lot of work in creating that spec and standardizing it. And, when an end user number 2 comes on board, they have a standard for electronics already, and then they can, make a clear decision on whether their use case aligns with that standard. And if it does, then, they use the existing standard. And if it doesn't, they might create a different spec. But what really, happens in this scenario is, if I am a manufacturer for televisions and I sell my televisions to 5 different retailers, now there are requirement is aligned across multiple retailers, right? In that way, different retailers communicate what they expect to see, in a standard way. So if I'm a television company, I know this is the requirement for retailer A, retailer B, retailer C. So that's what's ended up happening. Again, we started doing this for a few retailers, but what has happened over the years is other industries saw it and felt like this is something that they could use in their own industry. So, for example, the second industry that ARC has worked in the longest after retail is aviation.
Mhm.
So they have similar problems, right? They don't have retail stores, but they have different airlines, different airports, and different entities, all putting tags on, let's say, bags, but it has to work across the whole system.
Mhm.
The people buying the tag and putting it on the bag might not be the only ones who are scanning it. So the same approach of defining requirements and then evaluating product against requirements and communicating requirements has been again not something that's new. It has been done in other industries, but from an RFID perspective, we sort of inadvertently did that, right? So that's what ARC does. Yeah.
Perfect. Thank you so much. So let's take it all the way back. Whether it's airlines, whether it's retail, whether it's food, whether it's even things like toll roads, et cetera. RFID's been around for a long time. When I first got involved with this, when somebody said RFID tag, and I'm going to show this slide here because I think it helps to tell the picture.
Mm-hmm.
A lot of components to this thing. So when you say RFID tag, walk us through, and I've got several follow-up questions here, but walk us through the foundations of a tag, the difference between a tag versus an antenna versus an inlay. I've got a picture on the slide, but because I think it's confusing when people say tags. You can mean several different things. When somebody says RFID tag, what do you think?
Absolutely. And RFID is a very broad term, right? And we have discussed this in another podcast, where there are two, even in the name RFID, there are two parts of it, right? One is the ID, that's the data piece of it, and the RF is the radio waves that's used to communicate this ID.
Right.
So that concept, is used broadly across a whole slew of technologies. You got what we call as passive UHF RFID, which is what we use in retail, logistics, and that sort of applications. People still use the word RFID for active tags. So the difference between a passive tag and an active tag is the active tag has a battery in them. So anything like a BLE or even the Apple AirTags, you could call them as RFID as well, but they have an onboard power supply. And we use the same term for HF or NFC RFID, which is really short range, and the stuff that's used for financial payments or access control. Anytime you have a hotel room key that you tap or a credit card that you tap and pay, that's RFID as well. But it's more for close range applications.
Yep.
But what we tend to spend a lot of time on is the UHF RFID, which works about 10 to 15 feet in applications and is doesn't have an onboard power source and is really well suited for applications that you need to read items, and to know what's in a given area. So it's not really a one-to-one; it's a one-to-many. So you have one device that's trying to scan a lot of items.
But on this picture, so there's a tag.
Yeah.
On the left-hand side, what exactly is the tag? What am I looking at here?
Right. So then you're really looking at two things on the screen. So the one on the left is RFID in its, I would call the rawest form, or in its most basic structure, if you will. Okay. So on the sort of the middle, you see a dot. That's the IC or the chip. So that's the brains behind the whole tag, if you will, or the brains behind the whole device.
So that's, just to be clear, that's where the ID part goes, right?
Where the ID part, exactly.
What we have in that small chip is the ID information, and we'll get into tags data standard 2.0 later, but really it's just what? The UPC and the serial number?
Exactly. It's the SG10, it's G10 processor serial number where, we typically use G10s to identify things at a, item level, but at a unit level, you take, a G10, add a serial number to it, it becomes an SG10, right?
Right.
So it's a serialized unique ID, and it's typically, it used to be a 96-bit number, but we're moving beyond that in certain applications. But that 96-bit number is stored in that chip. So that's,
We're, we're showing we're showing on a screen here what constitutes the ID part, which is the UPC and unique serial number together. That's basically the SG10, serialized G10. And what that does is it gives you not just a UPC quantity, which the retail industry loves, but a UPC and a actual individual selling unit that you can track throughout the supply chain. I always say it's like a UPC and a VIN number in a car together. It's probably simple, but that's the way I can think of it, because you may have 1,000 F-150 trucks, but they're all different. They all have a different VIN number. So now in retail, every single selling unit has a unique serial number, SG10 for it. So
absolutely.
So that's what's stored in the tag. What's around the tag? Because the tag looks like it's about as big as a pencil lead. So what is around this tag?
So everything else that you're seeing, other than that little chip in the middle, is an antenna. Using your car reference, with the VIN numbers, think of the dot as the radio in your car, and everything else as the antenna that's connected to your radio, right? So you have a device that has the data in it. It has the capabilities to, communicate with other devices. So you got the brains there. And, you need an antenna to facilitate that communication, to sort of enable the RF side of it, the radio side of it. And that's essentially what you're seeing. So you have a chip that's connected to an antenna. An antenna is typically made of aluminum. It could be made of other materials as well, but it's a really thin sheet of aluminum that's connected to the antenna. And then it is, you see antennas with all shapes and sizes. We have one on the screen that is typically used in, automotive applications like tires, or, it's even sometimes used in aviation applications for bags. But then if you go and find an RFID tag in, an apparel item or a home improvement store, you will see that shape of the antenna a change. And that is typically done depending upon what you're building the tag for. So the chip remains the same, and then people design different antennas, if you will, depending upon the application. And then those are the two core components. So if you have a chip and you're connecting it to an antenna, you got a working RFID tag at that point. And then anything else that you're doing to it is really to protect it or package it or make it look good or integrate it with another application. So, you're essentially converting the tag to, to integrate it within the product. So the picture that you have on the right is sort of a converted RFID tag. So where you're taking the chip and the antenna and sandwiching it between two materials. And, the one side of the material could be essentially a paper that you can print on. And then the other side could be paper as well if it's a hang tag, or it could be adhesive with a release liner if you're making a sticker, or that same tag could be sandwiched between two pieces of corrugated cardboard if it's going on a carton. And at that point, it really, you're getting into the packaging phase of it.
Well, perfect. I picked Spec T, which to your automotive tires, because it showed up bigger. This could be just for dimensions. And so those could be like a 4-inch by 4-inch kind of label. But you have other ones for apparel and other things that literally could be as small as 1-inch by 1-inch, or
yeah. And then the goal is always to make it smaller. So in that way, it can integrate into the packaging seamlessly without having to people change packaging. Like when we started, doing this in 2009, the smallest tag we had was a 90 millimeter tag, right? Because those are built for 4-inch labels that would go on the side of a carton or even the side of a pallet. And it worked back then for the use cases. But as we moved into item level RFID, where we are tagging individual unique pieces of items. The tag had to get smaller so that it can be integrated better into the packaging. And it's year over year, the tags are getting smaller and smaller, right? Where we are tagging items, much beyond apparel right now. And, people are coming up with unique ways to create different sizes and form factors to fit those product needs.
So you led it beautifully into the next question. So you've been doing this since 2003. It's now 2024. We're literally 21 years into this thing. Talk to us about tag size, which you've already kind of mentioned, tag performance. Has it gotten better and faster and more reliable like most technologies, and tag cost? Not looking for quotes of tags, but give us a range of where both the performance and the costs have changed since 2003 to 2024.
Absolutely, Mike. So the growth that we have seen, or the evolution that we have seen, has been primarily driven by the use case and the volume needs. So when we were looking at this in 2009, the whole market for RFID at that point was somewhere around 30 million tags. And that was a lot, even, for us back then. But if you look at, some of the data that we have been looking at recently, last year we consumed more than 40 billion tags, right? So we started at, a really small niche volume on a path to potentially tagging trillions of items. So the technology has sort of, evolved to support that growing need. And like anything with technology, the need is always to make it cheaper, faster, or better. So, and I think we have, the industry has sort of stood up, or, has evolved to meet those needs. If you look at purely from a performance standpoint, being an engineer, that's what I tend to focus on and get excited about. The performance of the tags have, almost increased 100x compared to where we were, right? And a lot of, smart people have done a lot of great work to make that happen. To give you a little bit of perspective, not just purely on the performance side, even on the quality side, when we were doing this in, the case and pallet days, in 2004, 2005, we were our expectations of a good performing solution was in the 80s, right? So when we got an 85% re-rate, we considered this a success. Yes, we were, striving for something higher, but, we were happy with where things were back then. But if you look at the technology today, we are, I wouldn't call it 100%, but we are getting close to it at scale. That's the most important thing. And, there is increased confidence both on the performance and the quality side of it. There are enough retailers that are looking at, use cases like point of sale that have a financial transaction associated with it, so they can come to rely on it. So from a pure performance standpoint, we have made, significant changes, significant improvements. And then the other thing that also helps us, it has gotten significantly cost effective as well. When we were looking at costs back then, we were really talking about, fractions of dollars. When we got started in RFID, so that's what we, looked at, and that made sense at that point when we were tagging cases and pallets. But when we move to item level, that's hard to support. So today, I still remember the day Myron stood in front of a whole lot of suppliers in 2008, I believe, when we were starting our journey at Walmart with tagging denim and men's basics. And he said, 5 years from now, we need a 5-cent tag to go beyond.
By the way, that was Bruce Wilkinson.
Okay. Yeah.
That was Bruce. A little credit, throw a little shade Bruce's way. Bruce stood up and they all looked like he had 17 heads.
Exactly.
He's like, 5 cent tag. And they were like, a what? We're talking, I think they were 15 to 20 cents back then. I was like,
Exactly.
are you crazy?
Yeah, and I remember walking out of the room and every single solution provider in the that was in the room going, "What are these guys thinking? Are they grounded in reality? Do they know what they're asking?"
I think Myron followed up and now what Bruce said, 5 cents. That's what we're going to do. We are all, hey, it's 5 cents, boss. That's the new target.
Exactly. And we are at a place where we are way past that, right?
Yeah,
So.
exactly.
I think and that's a thing that we can expect to see as the technology evolves, as the manufacturing processes evolve, as we bring more technology innovation and scale to this. I think things are still going to keep moving in the right direction, so we can enable more and more products than what we are tagging today.
All right. If I hear this once a week, I probably hear it 15 times a week. Yeah, but Mike, RFID doesn't work with metal and water. All right, professor of RFID. It's gotten very creative about how we actually put RFID tags on products, right? So that really helps. But talk to us. So somebody came up and says, we cannot do this because it has all metal. We actually put RFID tags on data center equipment, right? There are tags specifically made that leverage that. So when you hear that, I'm sure you hear it more than I do, but it doesn't work with water and it doesn't work with metal. Walk us through kind of what the innovations have been, either from a packaging standpoint or RFID that actually works on metal or works very closely with liquids, et cetera. Just throw out some of the fallacies that are out there. I know one I heard the other day, and you and I laughed about it. Hey, it won't work on motor oil. Yeah, it actually works pretty good with motor oil. So walk us through what some of these perceptions that it doesn't work with this technology and what the real truth is.
Yeah, and then there is probably more, more of a misunderstanding on that than anything else on that topic, right? I still remember, a supplier coming back to us where in one of the playbooks that have been put out, where the statement was made saying that if your product has metal, review that particular product with either the RFID lab team or your packaging company to make sure RFID doesn't interfere with it. And they read that and their product, I believe, was televisions, or they were making some kind of an electronic device that had screws in them. And they were like, our products have screws in them, right? We put it in a cardboard box, but we're pretty sure it's not going to work on it, right? So sometimes people look at it in a way that they want to look at rather than, trying to get a fundamental understanding. But being serious here, yes, the thing with RFID is there are RFID tags that work across a broad range of materials. The simple answer to this is a tag, if it needs to be applied directly on metal, then a tag that's not designed for that particular application wouldn't work for it. Right. And that applies to anything else as well. You had a picture of the tags that we use in automotive tires. If you take the tag and put it on, an apparel item, you're not going to get the performance. And the same thing vice versa, where if you take a tag that's designed for apparel and put it on an automotive tire, it's not going to work well either. Sort of that same logic extends to metal, where you have to understand the product that you're working on and then create a solution that works in that environment. And what has changed is that adapting to that environment in this case, which is metal items like a metal trash can or a barbecue grill, the adaptation was not something that we were doing it at scale. As to your point, we've been tagging things in data centers for a lot of years. We have been tagging cars that have been going through the manufacturing process where the tag is directly applied on the body of the car before it goes into a paint shop. So we've been doing it, but for a mass application like retail, the challenge has been is how do we do it in a cost-effective and a scalable way that doesn't disrupt the whole, use case behind it. So what has changed in the last, I would say, 2 years is since there is no scale behind tagging metal items, right? Metal items are not really an exception. When you're doing apparel, a metal item is an exception. So when
Right.
you look at the whole apparel department, if you had 100,000 items, 99.9% of it was not metal. You had that one Kiwi shoe polish that sort of stood out, right? So developing a solution or adapting a solution for that one SKU didn't make sense. But we are now going into categories where there is a need to tag, millions of those. So now the companies that have been making these specialized tags that were focused on these niche applications are now developing products that can be scaled, that can be more cost effective to support these mass application of metal products.
Right.
So, and that's what we are seeing today is we are being purposeful about it. And then the other side of the solution is either you create solutions that work for metal, but we have also seen very, very, very creative solutions where people have modified the packaging to offset the tag from metal. And it doesn't really require a huge offset, and in fact, metal helps with RFID if you position it the right way. So
Yep.
people have been, been very creative about how do they adapt their packaging, especially since this is a technology that's here to stay, and most of the RFID tagging happens at source. They can do stuff like that. In the early days where they were not really sure whether this RFID thing is going to be relevant 2 years later, or if they were tagging somewhere else in the supply chain downstream. It was a challenge. But when you get the packaging and the production team involved, who sort of design the product from day one, when they take RFID into account, then they do come up with really, really creative ways to integrate RFID into their product or their packaging where it sort of works seamlessly.
Yeah,
Yeah.
maybe a few examples would be helpful because I think, clearly, and it's been public knowledge, but Walmart has been very, very aggressive about pushing the edge of the envelope to get outside of apparel, both doing apparel as well as pushing other boundaries, as well as people like Home Depot and Lowe's, et cetera. We're talking about stuff that's being tagged now, like golf clubs, like baseball bats, like cans of paint, aerosol paint, insecticide, lawn and garden stuff, liquids. And what's happening is we recognize physics. We're not trying to fight physics, right? We're never going to win against physics, but we learn to come up with creative solutions that allow us to get the tagging done while taking care of physics. I'll give you one example, and you probably have others, but I remember when I was working with one retailer that was interested in doing automotive tires, and they stored their tires in great big containers outside of a store. And we're like, half the team's like, well, that'll never work in there. And you and I were like, no, it's going to work fantastic. Because if you put the tires inside of a container and wand it, you'll probably wand all of those tags in about 13 seconds, if that, because it's going to bounce all over the place and get incredible reads. But if you try and read through a metal frying pan with a tag on the other side, you're fighting physics, right? So that's really why I like what you guys have done. You've come up with creative ways, working with obviously your customers, to figure out how can we put a tag on this and still work and make financial sense for the business. Is that kind of what you do? You're very creative when it comes to that kind of stuff.
Absolutely, Mike. And we take sort of the 90-10 approach, right? As you expand RFID into any new area, right? It can be in retail, it can be in other industries. You can sort of, figure out a solution for 90% of your products pretty easily based on what has been done before. And we take that approach and say, if your product or if what you're trying to tag fits within this category, here is a tried and tested approach, go for it, right? It has been done 1,000 times. It works. You don't even need to talk to us. But then there is always going to be that last 10% that doesn't fit a preset category or a preset model or a preset template. And those are the things that we have to essentially work with all the stakeholders, if you will, trying to identify a solution that works both from a technology perspective, but also has the feasibility to manufacture and deliver at scale. So our team, I got to brag on our team of students, where when we have that team, we call that as a product test team. They really do come up with creative solutions, right? And they also sort of keep doing this again and again and again and again, day over day. So something that might not, make sense or might not be relevant for that particular product category or that particular industry vertical, they might have seen something similar in another product category or another industry vertical, and they bring it in. And the same thing that's happening with not just us, but it's also the community as well. So for example, we were talking about aerosol cans, earlier today. So an aerosol can is all metal, right? And you can try to break your head trying to figure out how do we create a metal tag, but not only create a metal tag, but make sure we are applying or, attaching the RFID tag to a, aerosol can that's manufactured in a process where these cans are flying 300 feet per minute in their production process, right? And we don't want to do anything that slows them down. So that's when, what our team and a few of our partners that we work with realized all of these cans have a plastic cap on it, right? And they vary in shape and size. But the thing that really sort of solved the problem was, instead of trying to, again, attach a tag to the cap during the manufacturing process, they identified the manufacturers that make the cap themselves. And those companies were, I would say, much smaller in number compared to the companies that make aerosol products. But working with those plastic cap manufacturers, they were able to figure out ways to integrate RFID when the cap is made. So when the cap is delivered to the aerosol company, it's RFID enabled already. So the most that the product manufacturer had to do was encode the RFID tag rather than try to apply this on their manufacturing process. And again, it all makes sense when you look back at it, because when we talk about RFID at source, we are really talking about RFID at source. And it's not at the source of the product manufacturer, but at the source of the packaging company. And that's something that we have done in apparel. When apparel got rolled out, the apparel companies are not creating hang tags with RFID. The packaging companies are, right? So when the hang tag comes to the factory that's making the shirt, it already has RFID in it, right? But we really sort of lost that when we went into other categories, and we were expecting the product companies, the companies making aerosol cans, the companies making televisions, the company that are making the paint cans, now, trying to make changes to packaging, and they're not a packaging company. So it's going back to the, basics of it and saying, hey, this has to be really done at the source. And, sometimes we have to relearn our lessons, but things like that. And it's what makes this exciting, right? You're sort of solving one thing at a time, but once you solve it, you're solving it not just for aerosol cans, but you're solving it for anything with liquids or metal that has a plastic cap in it, right? So, and then it's something that translates not across retailer. You can do that for pharma stuff, and translate across industries as well.
So what I'm seeing as well is an integration of this technology across verticals. Obviously, you mentioned healthcare with pharmaceuticals. We mentioned the airlines. We mentioned NASA. We mentioned all kinds of things. The one big one to me is RFID in the food space. And some of that, McDonald's has been very, very, very open about what they're trying to do in terms of putting primarily case level RFID tagging for the tracking of merchandise, et cetera. But I'm working with a couple of retailers that actually want to get down to the item level, specifically, hey, could we do bread? Could we do packaged meat, et cetera? Walk us through the concerns, if any, because I know one thing that there was concern about as well, an RFID tag has metal in it. And if you defrost your bread or your packaged meat that you've frozen, you're a fire. Is that a real concern, or is that not a concern?
Yeah, I would say it's something to be aware of.
Okay.
Right, and take into account when you are making a decision on what to tag and who you're tagging.
Okay.
An RFID tag is, as we talked about, has two components, right? It has a piece of metal, it has a chip in it,
Yep.
and you put a piece of metal into your microwave. The typical thing that happens is, sparks fly, and that's just physics. But with a typical RFID tag on a typical product, that risk is minimized a whole lot, because what typically happens is you're not just sticking an RFID tag by itself into the microwave, you're putting it along with other products.
Yeah.
So there are, enough things with moisture in it where once you stick it into a microwave, all of the microwave energy actually goes to the food product rather than the RFID tag. So I wouldn't, address this as like something that I would, stop doing. But, you make sure that the tags, and there has been tags that are developed in the market where if someone even decides to put, something that like a container or something that doesn't have the product anymore, but wants to stick it directly into the microwave, there has been now tags that are developed that would withstand it. And then there are other ways to do it, right? There are other companies that have been expanding in home, where we are, selling Tupperware with plastic labels on, with RFID labels on them, that when people put Tupperware inside the microwave and heat things up, and not all of them remove the label. So one of the things that we have started doing is printing the word "please remove" before microwave, just as a safety thing. Consumers come up with creative ways to. I was talking to. This is totally off tangent, but I was talking to a company that makes fishing lures the other day, and they were going through a whole package redesigning process. And they were talking to us about, hey, how they can potentially change some of the RFID stuff since they're going through packaging redesign. And I was talking to them about, hey, what drove the packaging redesign process? And their answer was, there's marketing involved, but the one thing that they were trying to highlight was they have "do not eat" in really small letters. And they were getting enough calls from consumers who would call them and say, this fish bait doesn't taste well. This fish bait tastes spoiled, So that became a huge volume, and I'm not joking. Wow. And the whole redesign process was to make sure that we make those letters bigger so people don't eat. More importantly, don't eat and complain about how it doesn't taste good, right? So there are things that we have to do to make sure that, hey, we are covering, all our bases, but both from a practical standpoint and even from a solution standpoint, that I wouldn't consider it as a significant challenge.
Good. Because not to get into the original discussion, but when we expand the size of the RFID tag to say from a 96 to a 128, which is really not that big of a deal, that allows us to not only have that serialized G10, but have additional attributes about that. Unlike, what date was this bread made, so that the retailer can mark it down 3 or 4 days later and for a reduced sale before they have to throw it away. You can actually put data in addition to the serialized G10 into that. Let me ask a couple of last questions because we're running out of time. This has been a fascinating conversation. Number one, sustainability and recyclability. If I hear that once, I hear it 100 times. Yeah, but we're putting all this stuff into the environment and that's not right. And how do we do that? Talk to us about the sustainability and the recyclability of RFID tags on packaging.
Got it. So whenever we talk about sustainability, we sort of discuss two things and they sort of get intermingled. So the first thing is the sustainability impact that RFID as a technology has on the whole organization. It's a topic that I personally believe is not getting the recognition it should. It's very, very understated. Because when you look at how RFID works and the value that is being delivered to organizations, the way that we do things efficiently contributes directly to the bottom line of a lot of the sustainability goals that we have
Okay.
as part of a lot of organizations, right? There was a study that was done by a major retailer in UK who basically looked at the effect of RFID on the products that they carry, and they estimated that they had to ship 200 less containers
Mm.
across their supply chain to sell, or if in fact actually sell more than what they did last year, right? So that stuff, I think somebody said last week, the most efficient most sustainable container that we can ship across the ocean is the one that we don't ship,
Mm.
right? So so we reduce the amount of waste in not only in the shipping logistics of it, but the things that we throw away because we didn't know that we had that product, and we don't have a customer that's waiting for it. So I think from that perspective, I think there still needs to be a lot of research that's done to quantify it. The people that work in the industry sort of know and understand the inventory reduction that we have and the value that it brings to the industry. But then taking an even more narrow view and looking at RFID as part of the packaging, right? And what impact does it have on recycling specifically? If you look at, there are essentially two types of, packaging. One is paper packaging and one is plastic. I'm sure folks in sustainability are going to kill me for generalizing it at a high level. But from a sustainability perspective, when it comes to recycling on paper products, there has been multiple research studies that have been done across the globe that basically shows the impact that small chip and the little bit of antenna that we have doesn't fundamentally impact the recycling of paper packaging. So just by pure significance of the amount of materials that we have. And that has been a clear-cut case. There was even a lot of work that was done to remove the plastic substrate that is typically part of the antenna. But some of the recent research that has come out shows that, yes, that's a nice thing to do, but fundamentally, even if there is a small bit of plastic on paper recycling, then we should be okay. The other flip side of it is, the plastic packaging. So when you look at plastic recycling, anything that's not plastic affects plastic recycling. So if you take a plastic bottle like this and put a paper sticker on it, you're affecting the recyclability of the plastic packaging. And that's not really an RFID problem. You're putting, any sticker on it is a problem. And it was, something that was a concern initially because most of the RFID labels that we were creating in the industry back then had a paper face on it so that we can print stuff on it. But what we discovered was you can still accomplish the same thing without having a paper face. There are other places that you can print the same information in. So once you remove the paper part of the RFID tag and then use the same kind of plastic on the RFID tag that's on that's on the product, then you're sort of eliminating that concern.
Perfect. All right. Last question for you, Senthil. This is always a fun one.
Okay.
What's your message to the industry, specifically the solution providers? I know you spend a lot of time with solution providers. What do they need to start, stop, continue doing in terms of continuing to leverage RFID for all of these various industries? What would you like to see them start doing and stop doing and continuing doing to continue to drive the application of this technology?
Great question, Mike. Probably need another podcast just for that. But let me think of a couple of things.
Answer it.
So one thing I want to say is, the industry has sort of stepped up. I want to make sure that they're getting credit for what they have accomplished. Technology is day and night, compared to where we were 15 years ago. And there has been a lot of bright minds that have contributed to making this work, at a scale that, it's working at right now. And and getting ready for the future as well. So on a broad level, I think we are moving in the right direction. But if I had to find a couple of things that they could really focus on, the one thing, and I'm going to steal from Matt Alexander, who runs the Walmart program today, is, if you look at the RFID industry today, the biggest consumer of RFID tags is apparel. But that's sort of, from our perspective, set and done, and we are moving aggressively beyond apparel in retail, and we are moving aggressively in other industries as well. And if you look at a lot of solution providers, they grew up with apparel, right? And we sort of have the same problem as well. Whenever we move beyond apparel, we sort of try to work with the apparel mindset. And, when we move to these other industries, yes, we could have our learnings from apparel, but sometimes you have to sort of forget a lot of those and, step back and rethink the whole thing to see what would really work for this industry. What is the thing that we have to solve to enable this industry in the most efficient way, rather than trying to shoehorn what has worked in apparel, right? And that's hard to do because you have a day job where you are still focusing on apparel, but you're also supporting growth. I think that mindset, it's there, but it's hard to balance. I think that's one thing. And I think the other thing that's also happening, but I would want to emphasize, is the collaboration, right? Where you have RFID companies who are experts in RFID, but then there are packaging companies who are experts in packaging, but not experts in RFID. And then you have product manufacturers who know, their products, how it's made. And when we move beyond, again, apparel into these new industries, a collaboration makes a lot of things easier. Sometimes you have to just put them on a call together, and, at the end of that, you solved it, rather than all those three entities trying to do it on their own. So it's really reaching out across the industry and solving it together. So, I think that we couldn't we couldn't have enough of it.
I've known you since 2003.
Yeah.
You first started in the lab. The amount of progress we've made as an industry, just think about it. We were not doing RFID at all to now we're 40 billion tags. We've got major retailers like Walmart and Nordstrom's and Dick's Sporting Goods and Target and Macy's and all these other folks who are actively counting on this technology to drive on-hand accuracy and on-shelf availability. Mm-hmm. We've reapplied it to the aviation, to pharmaceuticals, to food. And frankly, without the backbone of delivering technology, whether it's a tag and a reader, and working with solution providers and tag manufacturers and packaging providers and customers, et cetera, we wouldn't be where we are. And I give you a lot of credit for that. Yeah, you will not be humble enough, or you will be way too humble to take any credit for it. But I got to tell you, I happen to know that there are very many days where you just get beat up day after day after day by different solution providers. Why didn't this pass? It should have passed, et cetera. But frankly, you're drawing a line in the sand that says if it doesn't pass the requirements for performance, it will get out into the marketplace, it will fail, and then we'll have people saying RFID failed. And you refuse to let that happen. So I want to thank you on behalf of the industry, because we would not be where we are without your tremendous leadership, your collaboration, and frankly, your tenacity to look for solutions that are really outside the box. So thank you for all you do. We'll probably get back on another podcast and talk about more stuff, but just the foundation of how tags work and what the evolution has been and all the stuff behind it, I think is going to be really helpful for our audience. So thank you very much.
Thank you, Mike. And, and I must say this, right? Sometimes my name gets used more than it should, mostly on the credit side, but all we do is sort of like facilitate it, right? You have end users that have the vision and are driving the industry and, and are really looking for our help to get there, right? And then you've got all these technology providers who are coming up with innovative solutions year over year, surprising us. And then we have a huge team here in the lab who does all the real work. And yes, I do get my share of complaints, both from end users and technology providers. But I think that's very small compared to all the credit I get. So it's really, I would say, very fortunate to be part of this community. I wouldn't have it any other way.
You're kind of guy. You're like the Wizard of Oz. You're the guy about turning all the levers and the smoke's coming out, et cetera. But you're back there driving the bus. So you're too humble to just say thank you. You want to give credit for everybody else. But Senthil, I really do appreciate it. I appreciate your friendship. I appreciate our collaboration over the years, and keep doing what you're doing, man. Because it feels like we're just getting started in other business and other categories, and it's really fun. And we thank you as an industry for all your hard work.
Thanks, Mike. Looking forward to the next 20.
Okay, take care.
Take care. Bye.
Bye-bye.